So, dear students, welcome to our next class in the topic of notches and weirs. So, last two class we studied notches and weirs of shape rectangular and triangular. So, this class we will discuss trapezoidal, notch, and weir. Okay, you can see in this picture. This is a trapezoidal notch. So you can see deeply means a trapezoidal notch consists of both rectangular notch as well as a triangular notch. So in this figure 8.4, in this trapezoidal notch, so AFD and BEC. Okay. So this you can merge this two triangle, it will form a one triangular notch and A, B, C, D. So this is a rectangular notch of height h. Okay. So the trapezoidal notch is nothing but it is a combination of triangular notch and a rectangular notch. So you can see here a trapezoidal notch or weir is a combination of rectangular and triangular notch or weir. Thus, the total discharge will be equal to the sum of discharge through a rectangular notch or weir and sum of discharge through a triangular notch or weir. Okay, since it is the combination of both triangular and rectangular notch, the discharge also the sum of rectangular notch and triangular notch. Okay. So here CD1, there are here we have to apply two CDs. Okay, you know about CD. CD is nothing but coefficient of discharge of a particular notch. So CD1 is nothing but coefficient of discharge of a rectangular notch. Okay, so there are two portions there. One is rectangular, other one is triangular. And CD1 is the rectangular portion, coefficient of discharge, and CD2 is the triangular portion, coefficient of discharge. Okay, the discharge through a rectangular portion A, B, C, D, as seen in the previous slide in that figure. The discharge through the rectangular portion. We know that rectangular notch formula, discharge formula. So here I mentioned Q1. Q1 is the discharge through rectangular portion Q1 and Q2 is the discharge through triangular portion. So for Q1, 2 by 3 CD1 into L into root 2G H power 3 by 2. So this is the first equation we already seen in rectangular notch. So same formula. So instead of CD, here I written CD1 because here there are two CDs are there. Okay. So next come to triangular portion. So Q2 is equal to 8 by 15 into CD2. Okay. Into tan theta by 2 into root 2G H power 5 by 2. This is number equation 2. So equation 1 is for rectangular portion and equation 2 for triangular portion. So for we need trapezoidal portion means the summation of Q1 plus Q2. The summation of Q1 that means discharge through rectangular portion and discharge through triangular portion. The summation of these two equation gives the total discharge in the trapezoidal portion. That means the trapezoidal notch or weir. So the summation of Q1 plus Q2, which is equal to 2 by 3 CD1 L root 2G H power 3 by 2 plus 8 by 15 CD2 tan theta by 2 into root 2G H power 5 by 2. Okay. So this is the equation. So this is the diagram of the trapezoidal notch. Okay, the water is flowing in the trapezoidal notch. So before that, one scale is there to measure the depth of the water or head of the water. and this also a real trapezoidal notch. So this is made up of a metallic plate. Okay, and this is also one of the trapezoidal notch. So water is flowing in the trapezoidal notch. And here also one trapezoidal notch is there. So you can see here a scale is fitted to measure the depth of the water in the notch. So let us see a problem in the trapezoidal notch. So I'll read the question, please follow. Find the discharge through a trapezoidal notch which is 1 meter wide and at the top and 0.4 meter wide at the bottom and is 30 centimeter in height. So here you can see the top width, bottom width is given in terms of meter, but the h, okay, h is given in centimeter. Okay, so you have to convert all the units into meters. Okay, whatever they will give a centimeter or whatever maybe you must convert into meter first in the given data question. Okay, the head of water in the notch is 20 centimeter. That means head h is 20 centimeter above the crust. Assume CD for the rectangular portion is 0.62 while the triangular portion is 0.6. So as we discussed earlier, there are two CDs. Okay, one is for rectangular portion, another CD is for triangular portion. So for rectangular portion, the coefficient of discharge is 0.62 and while the triangular portion, it is 0.6. Okay. So top width is 1 meter. AE. So here this is the diagram of the trapezoidal notch. The top width AE is 1 meter and the base width CD is 0.4 meter and head of water. Okay, head of water is 0.2 meter. Head of water means the distance between the crust. Okay, that means this is called a crust. This portion is called crust. That means bottom of the notch. The distance between the crust to the top surface of the water. Okay, so it is mentioned as capital H. This capital H is 0.2 meter. Next, coefficient of discharge CD1 0.62. It is given in the question, and triangular portion also coefficient of discharge given in the question. It is 0.6. Okay, so now we will start the problem. So what are the data we needed? You can see the first you write the equation. What is the discharge formula for in case of trapezoidal notch? It is the summation of the discharge of rectangular portion and triangular portion. Here, what are the data we needed? So CD1 they given in the question, L they given in the question, and H also given. And here also CD2 given, H also given. The only unknown parameter is theta. Okay. So from this figure, you can see this portion is theta by 2. Okay. So this theta by 2, they didn't give in the problem. So for that only, we have to find this theta by 2 as the first step. Okay. So now take this triangle ABC because ABC and FED both are same, symmetrical only. So we can take any one. So I'm taking ABC triangle. So in this triangle, the included angle is theta by 2. So tan theta by 2, which is equal to, what is meant by tan theta? Opposite divided by adjacent. Here, what is the opposite side? AB. This is your opposite side. And adjacent side is BC. Okay. So AB divided by BC. How to calculate AB? AB also not given in the question. So AB we can easily find. How? So first, what is the total length top with AE? Okay, so this length is AE, and we minus this portion. That means BF portion. We can get this this length, the summation of this length and this length. Okay. So these two lengths are equal. So divided by 2. So AE minus BF, AE minus BF divided by 2. Okay, divided by 2. So this is your AB length. So here you can see AE minus BF. What is BF? BF and CD both are same length. So AE minus, either you can write CD or you can write BF. BF. So both are same length. CD and BF both are same length. Okay. So I am considering BF. So AE minus BF divided by 2. Next, BC. This is your adjacent side. Adjacent side is nothing but the head of the water, capital H. So that capital H height is 0.3 meter. So here they mentioned in terms of meter. You must convert it into, they mentioned in centimeter. You must convert it into meters. So it is 0.3. So now tell me, what is AE? AE is 1 meter top width, and BF is 0.4 meter. That means bottom width. Okay, 0.4 meter bottom width divided by 2 divided by, and BC is the height is 30 centimeter. It is 0.3. So finally we got tan theta by 2, which is equal to 1. Tan theta by 2, which is equal to 1. Okay. So apply this tan theta by 2 equal to 1 in this equation. So except this tan theta by 2, all the values are known values. So substitute all the value. 2 by 3 CD1. CD1 is 0.62 into L. L is the 0.4. That CD length is nothing but that means bottom of the crust is nothing but L into root 2 into 9.81. G is 9.81 and H is the head of the water. That means 0.2. Okay. Plus 8 by 15 into CD2 is 0.6 into 1. Tan theta by 2 is 1 into root 2G 9.81 into 0.2 power 5 by 2. Okay, H is 0.2. So substitute all the values, we can get the final answer. It is 0.09084 meter cube per second, which is equal to 19.84 liters per second. Okay. So here this H is 0.3 and this H is 0.2. Okay. So here in the question they given height of the notch, and the head of the water over the notch is 20 centimeter. So here you have to put height of the notch, but this H is mean for head of the notch. Okay, while substitute, be careful. In this equation, you have to put head of the notch. While calculating tan theta by 2, it is the height of the notch. Okay. So next, velocity of approach. So what is meant by velocity of approach? So you know that water is flowing in a medium, that means considered as a notch or weir. So in the upstream side, the velocity is low, while at the time of fall, in the notch or weir, okay, that means at the time of falling in the downstream side, that means that nappy portion, nappy we already discussed. Okay, so that nappy portion, the velocity is high. Okay, so that velocity also we must include it in the formula. That is called velocity of approach. So how to include? How to calculate that velocity? That means that nappy velocity at the time of falling from upstream side to downstream side through the notch. The velocity will be somewhat higher. Okay, so how to calculate? So let us discuss in deep. Velocity of approach is defined as the velocity with which the water approaches or reaches the weir or notch before it flows over it. Okay, so when reaches the notch of weir before it flows it, so we must consider that velocity approach. Thus, if VA is the, so V means velocity here in the subscript we mentioned A, that A is called approach. So VA is the velocity of approach. Then an additional head. Okay, HA which is equal to VA square by 2G. We know that head in Bernoulli's equation we discussed velocity head formula is V square by 2G. So here VA square. Okay, because it is we are considering velocity approach. So VA square by 2G due to velocity of approach is acting on the water flowing over the notch. Okay, so then initial height of water over the notch becomes h plus HA. So this HA is nothing but this velocity of approach. Using this formula, we have to calculate. So h plus HA. And the final height becomes equal to HA. So initial height is head plus head of water due to velocity approach, and final height is HA. Then all the formulae are changed, taking into consideration of velocity of approach. The velocity of approach VA is determined by finding the discharge over the notch or weir, neglecting velocity of approach. Then dividing the discharge by the cross-sectional area of the channel on the upstream side of the weir or notch. The velocity of approach is obtained mathematically. So VA. So how to calculate discharge? Sorry, discharge is you know that meter cube per second. So from that discharge, how to calculate the velocity? So discharge divided by area of the channel. Once you found the discharge, from that divided by area of the channel, we can easily get the velocity of approach. So thus velocity of approach is used to find the additional head. So from using this VA, we have to calculate this HA. How to calculate? Using this formula, VA square by 2G. Again, the discharge is calculated and the above process is repeated for the more accurate discharge. Suppose we want to know the accurate discharge in the rectangular, via triangular or trapezoidal, we must include this HA in that formula. So discharge by rectangular weir with velocity approach. So previously we seen the formula without velocity approach. Okay, without velocity approach. And the last term we used h power 3 by 2. But here, while considering the velocity approach, the formula will be slightly changed. That means 2 by 3 CDL into root 2G H1 plus HA. H1, the summation of H1 plus HA power 3 by 2 minus HA power 3 by 2. So this is the formula for rectangular notch. So same like for triangular notch. Triangular notch also we have H power 5 by 2. Okay, that we will see in next. First we will discuss a problem in the rectangular notch considering velocity approach. Okay. So water is flowing in a rectangular channel. Water is flowing in a rectangular channel of 1 meter wide and 0.75 meter deep. Okay. So consider a rectangular channel. It is 1 meter wide and 0.75 meter deep. Okay. This is the rectangular channel meter. Find the discharge over a rectangular weir of crust 60 centimeter. If you convert that into meter, means 0.6 meter. Okay. If the head of water over the crust of weir is 20 centimeter and water from channel flow over the weir, take CD equal to 0.62. Neglect end contractions. Take velocity of approach into consideration. What is by end contraction? End contraction means neglect. There is no end contraction means the channel width is same as weir width. Okay, the channel width which is equal to weir width. So previously we seen some of the pictures. In that pictures, channel width is more, but the notch and weir width is small. Okay, so neglect end, there is no end contraction means the channel width which is equal to that weir width. So both are same. The width of channel width and weir width both are same. So take velocity of approach into consideration. So here you can see A is equal to 1 into 0.75. That means area. So the weir area is same like same as channel width. So 1 meter into 0.75 meter. And the length 0.6 meter, H1 0.2 meter, and CD is equal to 0.62 meter. Now discharge over a rectangular weir without velocity approach. So first, what is the first? We need to calculate the discharge. That is the first step. So since it is a rectangular weir, we must calculate initially without considering velocity approach, because we don't know HA. Okay, so we want HA means first we need to calculate Q without considering velocity approach. So okay, so for without considering velocity approach, we know the formula 2 by 3 into CDL into root 2G H1 power 3 by 2. H1 or H. Okay, so 2 by 3 CD is 0.62 into length. Length is 0.6. So crust, you can see crust length is 0.6 into root 2 into 9.81 into H1. H1 is 0.2. That means 20 centimeter. Power 3 by 2 meter cube per second. So this is the discharge formula, and finally we got discharge of 0.0982 meter cube per second. Okay, 0.0982 meter cube per second. So velocity of approach VA is equal to Q divided by A, which is equal to discharge 0.0982 divided by area. Okay, so we calculating the channel area. So first we have to calculate the channel. That means before the weir. Okay, we must calculate it before the weir what is the discharge. So same discharge only falls under after the weir. Okay, so VA is equal to Q divided by A. So for how we calculated this 0.75? So 1 into 0.75. That means the channel width. Okay. So we got VA is equal to 0.1309 meter per second. Okay. So using this discharge form, discharge value, we calculate VA. So additional head HA. So now imagine that water is now entering into the weir. So this before discharge and VA is before the weir. Okay, now the water is entering into the weir. So we have to calculate the additional head, that is called HA. So using this formula, VA square by 2G, which is equal to, so VA we know 0.1309 square divided by 2 into 9.81. So HA we got additional head 0.208733 meter. So this is the HA. So now apply again, you have to repeat the discharge formula by incorporating the velocity approach. So Q is equal to 2 by 3 CDL root 2G H1 plus HA power 3 by 2 minus HA power 3 by 2. So substitute all the formula. what are the known values you can substitute in this formula? So 2 by 3 into CD 0.62 into length 0.6 into root into 2 into 9.81. So H1 is 0.2 plus HA is 0.00087 power 3 by 2 minus 0.00087 power 3 by 2. So finally we got final discharge is 0.09881. Okay, so this discharge is this Q. This discharge is considering the velocity approach. So now finally you can compare this discharge and this discharge. What we observe. Okay. So what we observe from this two. So compared to this Q value, this Q value slightly increases. So here you can see 0.0982, but here 0.09881. Okay, so why it is increases? So because we considering the velocity approach. Okay, slightly, not more, very slightly it will increases. Discharge will be increases while considering the velocity approach. Okay, so while doing problem, you can cross check. This should be slightly only, it will increases, not much more. Okay, so this is the procedure for calculating the velocity approach. First, we have to calculate the discharge without considering the velocity approach. After that, we have to calculate the velocity approach using that discharge VA. After that, the third step is additional head. Additional head HA is equal to VA square by 2G. Okay, from that additional head in terms of meter, we can get. Finally, we have to adopt that HA into the discharge formula with velocity approach. Finally, we get the answer and compare the answer. That means discharge before the velocity approach, discharge after the velocity approach. Okay, so slightly it will higher. So next we will move to next problem. Find the discharge over a rectangular weir of length 100 meter. Okay, so imagine 100-meter length, that rectangular weir. The head of water over the weir is 1.5 meter. The velocity approach is given by 0.5 meter per second. Listen, students, in this question, the velocity approach is given, directly given. That means VA. So in previous problem, we calculated VA using the discharge. But in this problem, they directly given VA. So this problem is very simple. Take CD is equal to 0.6. So write down the data given. Length of the VR 100 meters. Head of water H1 1.5 meter. And velocity of approach VA is equal to 0.5 meter per second. And CD value 0.6. So now only thing is we have to calculate the additional head. How to calculate additional head? Using the formula. HA is equal to BA square by 2G, which is equal to, so what is BA? It is given in the question 0.5. If it is not given in the question, means first to calculate discharge. Then the discharge divided by area of the channel, we can easily get the VA. Okay, so HA is equal to 0.0127 meter. Okay, so now the discharge Q over a rectangular weir due to velocity of approach is given by the equation. So Q is equal to 2 by 3 into CDL into root 2G H1 plus HA power 3 by 2 minus HA power 3 by 2. Okay, this is the formula. Now substitute all the values in this formula. So 2 by 3 into CD is 0.6. So CD value also not given. So sometimes in the question, the CD value they may not given. Okay, so what to do means you have to assume. You have to assume. Okay, so how to assume? So it is nearer to 0.6, 0.6 to 0.6 by any value you can assume. If not given means the question. If given means you have to substitute that value only. So CD 0.6 and the length. Here they given length 100 meter and root 2 G into H1. H1 is 1.5 meter plus HA. HA is here we calculated 0.0127 meter. This is your HA minus HA power 3 by 2. Okay. So in this equation, the only unknown value is HA. So for that we calculated here. So now substitute all the values in this HA and finally we got 329.35 meter cube per second. So this is the final answer. Okay. So if velocity of approach, please read this line. The velocity of approach is given as 0.5 meter per second. So in the question it is available means you can directly calculate HA. If not available means first you have to calculate the discharge. After that discharge divided by area we can get the VA. Discharge divided by area what? It is velocity. Okay. So that is the main thing. So now we will see the next problem. A rectangular weir of crust length 50 centimeter is used to measure of rate of flow of water. What is another name of rate of flow? It is discharge. In a rectangular channel of 80 centimeter wide and 70 centimeter deep. Determine the discharge in the channel. If the water level is 80 mm above the crust of weir. Okay. Take the velocity of approach into consideration and the value of CD 0.62. So here velocity of approach is not given. So first we have to calculate the discharge. After that velocity approach we have to calculate. So write down the data given. So length how much? 50 centimeter and area 80 centimeter into 70 centimeter. This is area of the channel, not weir. Okay. So 80 centimeter into 70 centimeter you converted into meters. So we got 0.56 meter square. And head over the weir is H is equal to 80 mm. So if you please listen, it is given in mm. You must convert it into meter. 80 divided by 1000. 1000 mm is equal to 1 meter. So 80 divided by 1000 we can get in terms of meter. CD is 0.62. Okay. The discharge over a rectangular weir without velocity of approach is given by equation 8.1. So what is the equation? We already know 2 by 3 CDL root 2G H power 3 by 2. So this is without velocity of approach. Okay. So first step is we have to calculate discharge without considering velocity of approach. So this problem same as like a first problem. Okay. So 2 by 3 CD is given 0.62 and the length of the weir 0.5 into root 2 G 2 into 9.81 into H. H is 0.08 power 3 by 2 meter cube per second. Okay. So finally we got discharge value 0.0207 meter cube per second. 0.0207 meter cube per second is the answer. Discharge. Now calculate the velocity of approach. That means velocity VA is equal to Q divided by area of the channel. This is not area of the weir. If you put area of the weir means it is wrong. We have to put area of the channel. So why? Because we are calculating discharge. That means velocity approach before the weir. So area is 0.56. So finally we got VA is equal to 0.0369 meter per second. Okay. Next head due to VA. So HA is equal to Head means HA. HA is equal to VA square by 2G, which is equal to 0.0369 square divided by 2 into 9.81. So finally we got head. That means head due to velocity of approach. It is 0.000697 meters. Okay, so this is the head. Now applying this HA into the discharge formula, considering velocity approach. So Q is equal to 2 by 3 into CDL into root 2G H1 plus HA power 3 by 2 minus HA power 3 by 2. Okay, so 2 by 3 into CD. What is CD? CD is 0.62 into L is 0.5 into root 2 G is 9.81 into 0.08 plus 0. HA. HA is here 0.000697 power 3 by 2 minus 0.000697 power 3 by 2. So simplifying all the datas, and finally we got discharge by considering velocity approach. We got 0.2073 meter cube per second. 0.2073 meter cube per second. So this is the discharge value we got. Okay. So simple thing. First calculate the discharge without considering the velocity approach. Next, we are coming into velocity approach, that is VA is equal to Q divided by area of the channel. Then head due to VA, HA is equal to VA square. So these all the formulas are interlinked one. So first Q and VA is equal to Q by A and HA is equal to VA square by 2G, and finally discharge with velocity approach, we are adopting that HA in that formula. So all are interlinked. Okay, so we have to write step by step all the formulas and calculate the final answer. 0.2073 is the final answer. Okay. So next we will see the next problem. A suppressed rectangular weir is constructed across a channel of 0.77 meter width with head of 0.39 meter and the crust 0.6 meter above the bed of the channel. Estimate the discharge over it. Consider velocity of approach and assume CD is equal to 0.623. Okay. So now write down the data given. So the channel width is given 0.77 meter and head to over the weir. Head to over the weir is 0.39 meter. Next, height of the crust from the bed of the channel 0.6 meter. Okay. So here you can see, I will draw the cross section for better understand. So this is the cross section of the weir. So water is flowing like this. Okay. So channel width is 0.77 meter and head of the water 0.39 meter. That means this height is 0.39 meter. 0.39 meter. Okay, and the crust 0.6 meter above the bed of the channel. So this is crust. This crust height is 0.6 meter. 0.6 meter. Okay, above the bed level. So this is called bed level. BL, bed level. Okay, now tell me what is the height, overall height, depth of the channel, overall height from here to here. So it is nothing but 0.6 meter plus 0.39 meter. 0.6 meter plus 0.39 meter. So that is your depth of the channel. So why we need depth of the channel? For calculating the area of the channel. So in previous case, yeah, size of the channel is given, but here size of the channel is not given. So they indirectly given the size. That means from bed level to crust, and this crust to head of the water. So we have to add both these two values to find the overall depth. Okay, that is your depth of the channel. It is 0.99 meter. So substrate wear means that the width of the channel is equal to width of the wear. So suppressed wear means, what do you mean by that? Suppressed wear means width of the channel which is equal to width of the wear. That is, there is no end contractions. There is no end contractions. Okay. So maybe in 2 mark they will ask what do you mean by suppressed wear. So in suppressed wear there is no end contraction. So the width of the channel which is equal to width of the ear, it is 0.77 meter. And area of the channel equal to width of the channel into depth of the channel. It is 0.77 into 0.99. So the discharge over the rectangular weir without velocity approach. So first we have to calculate without velocity approach. So Q is equal to 2 by 3 into CD L or B into root 2G h power 5 by 2. So here L or B. So width equal to, sometimes they will tell L or B, both are same. It is 0.77. CD is 0.623. It is given in the question. So root 2 into 9.81. And head of the water. What is head of the water here? 0.39 meter. So finally we got, that means before velocity of approach. It is 345 meter cube per second. So now calculate the velocity of approach. So Q is equal to, VA is equal to Q divided by area of channel, which is equal to 0.345 divided by area. Area of the channel how much? We already calculated 0.77 into 0.99. So in this problem, area of the channel and area of the weir both are same. Okay. So it is 0.99. 0.77 into 0.99, which is equal to 0.4526 meter per second. Okay, this is BA. So from this BA, we have to calculate the HA. So HA is equal to VA square by 2G. Head of water considering velocity approach. VA square by 2G. So substitute BA 0.4526 square divided by 2 into 9.81, which is equal to 0.0104 meter. So now the discharge with the velocity of approach is given by Q is equal to 2 by 3 CDB or CDL, you can write L, into root 2G H plus HA power 3 by 2 minus HA power 3 by 2. Okay, so substitute all the values. L is equal to 0.77, CD is equal to 0.623, and capital H 0.39. 0.39 is the head of the water above the crust. Okay, and HA is equal to 0.0104. So substitute all the values. We got 0.3573 meter cube per second. 0.3573 meter cube per second. So this is the final answer. Okay. So this type of problem, if they given, means we have to calculate two discharges before velocity approach, and final answer we got from the after the velocity of approach. Okay. So next thing, another trapezoidal weir. It is called Ciplotti weir. Ciplotti weir. What is Ciplotti weir? What is the difference between previous we seen some trapezoidal channel? What is the difference between that channel and this channel? So in Ciplotti weir, the side slope is constant. That is 1 in 4. That means 1 horizontal, 4 vertical. Suppose it is this is 1 meter, means this is H is 4 meter. That is called Ciplotti weir. Not H. This overall depth. This overall depth is 4 meter. Okay. That is called Ciplotti weir. Ciplotti weir is a trapezoidal weir which has side slope of 1 horizontal and 4 vertical as shown in figure. So this may asked in 2 mark question or 3 mark question. So for this tan theta by 2, AB divided by BC. Here AB is 1 meter and BC is 4 meter. So this is 1 meter and BC is 4 meter. So we can get tan theta by 2 is equal to tan 1 by 4 is nothing but 14 degree 2 minutes. 14 degree. So this is constant. This is constant. So in simplicity we are that side slope is constant. The angle, included angle of the triangle is 14 degree 2 minutes. This is constant 1. Okay. So now we will discuss the one problem. Find the discharge over a simplicity weir of length 2 meter when the head over the weir is 1 meter. Take CD is equal to 0.62. Okay. See, formula, everything same. Formula and everything same. So the equation discharge is given by 2 by 3 CDL root 2G h power 3 by 2. So 2 by 3 into CD L is 2 meter and root 2 G into h power 3 by 2. H power 3 by 2. H is 1 meter. Okay. So substitute we can get 3.661. Okay. So this is answer for rectangular portion. Okay. Same way calculate triangular portion. So that answer I didn't mention here. So same way calculate for triangular portion. In the triangular portion, tan theta by 2. So for that we have to substitute 14 degree. Okay. Tan 1 by 4 is 14 degree or tan theta by 2. In that place, theta by 2, in that place you put 1 by 4. So tan 1 by 4. Okay. So finally, the summation of rectangular portion and the triangular portion. Okay. We can get the final answer. That is the answer for the problem. Okay. The simplicity weir problem. Okay. Here, unfortunately, I didn't mention the triangular portion. So you can calculate yourself. Okay. So this is for Q1 and Q2, that formula 8 by 15 CD tan theta by 2 into root 2G h power 5 by 2. Okay. In that tan theta by 2, tan you put instead of theta by 2, you put 1 by 4. That's all. So finally we get the final answers. The summation of Q1 plus Q2, we get the final answer. Okay, students. So up to this notch and weir. Okay, so weir portion is over. So next class we will discuss the one type of weir they mentioned in the syllabus. It is called broad crusted weir. Okay, in that broad crusted weir, one problem is there. Okay, we will discuss broad crusted weir. After that, we will see one problem. Okay, so for up to that, the third unit is over. Okay, students. So thank you for understanding. If you have any doubts and queries, means you can ask me. Thank you.